is Physics Chapter 2, Problem 67, and it says, when jumping a flea reaches a takeoff speed of 1 meters per second over a distance of 0.5 millimeters, part A is asking what is the flea's acceleration during the jump phase. So to find his acceleration, we have to use this equation. Velocity final squared equals velocity initial squared plus 2a times the change in x. So to make everything easier, we're just going to convert 0.5 millimeters to meters, and so that gives us, there's 1,000 millimeters in 1 meter, so that gives us 0.5 times 10 to the negative 3 meters. And so it gives us our final velocity, which is 1 meters per second. It gives us our initial zero. We add 2a. We don't know our acceleration, and we know our change in x, which is this value we got here. And so to solve, we have to solve for a, and when you solve for that, you get 1 over 2 times 0.5 times 10 to the negative 3. And then that should give you 1,000 meters per second squared. That's our acceleration. Part B is asking us how long does the acceleration phase last. Okay, so to find our time, we're going to use this equation. X final equals x initial plus velocity initial of x times time plus 1/2 times acceleration and times t squared. So we have our final x, which is 0.5 times 10 to the negative 3, and then our initial 0, our velocity initial 0, and so is our x, so that just leaves 1/2 times our acceleration, which is 1,000 meters per second squared, and then times, we don't know our t squared. So when we solve for t squared, we should get 10 to the negative 6, and then we have to square root that, and we should get t equals 10 to the negative 3 seconds, so it's 1 millisecond. And then C is asking us, if the flea jumps straight up, how high will it go? Ignore air resistance for this problem. And so to find how far it goes, we do velocity final squared equals velocity initial squared plus 2a times the change in y. And then we have our velocity final squared. Our velocity final is 1. Our initial is 0. And then we times it by the acceleration of gravity, which is negative 9.81. And then we're trying to find our change in change in y. And then when you do that, you get 0 minus 1 squared over 2 times negative 9.81 equals our y final minus our value, which is 0.5 times 10 to the negative 3, and when you solve that, you get 5.15 times 10 to the negative 2 meters, and that's just 5.1 centimeters.